Hello, and welcome to this presentation on adipose tissue and its cellular composition. My name is Stu Williams. I'm a cell biologist who's been studying adipose tissue and especially methods for the isolation of cells from adipose tissue for over 50 years. One of the first evaluations of the formation of adipocytes and fatty tissue was performed by an investigator by the name of Fleming in 1871. And these studies led to several conclusions. One, several types of fat can form, particularly lobular fat, as well as a more diffuse adipose tissue or fat throughout the body. And most importantly, he described that the adipocytes, the fat cells themselves, did not come from some sort of a specific pre-adipose cell. There seemed to be multiple cell types involved in the formation of adipose tissue. This study was followed many decades later by what I consider one of the penultimate studies and original studies of where fat cells come from inside mammalian tissue. This study was performed by two anatomists, husband-wife team, Elliot and Eleanor Clark from the University of Pennsylvania. And in their studies, they utilized a chamber in the ear of rabbits, and they watched and took photographs as fat tissue formed. And one of the most important conclusions from these studies was the fat cells were formed in the direct presence of blood vessels. They began to reach the conclusion that blood vessels, and specifically the endothelial cells of blood vessels, were very important to the formation of adipose tissue, and began to develop a hypothesis that adipocytes were formed from the blood vessels inside connective tissue. So where do we go as far as, since the publication by Clark and Clark of these microscopic images, and in this slide I show you all of the different studies and what I consider some of the most important studies on the formation of adipocytes, as well as other cells inside fat tissue. 1952, one of the foundational textbooks of histology came to the conclusion that adipocytes form in the presence of other connective tissue cells. In 1963, an investigator by the name of Napolitano found that the differentiation of white adipose cells came from vascular cells. And this was the first study using the electron microscope to study the formation of these cells. And then in a series of studies starting in 1975, the development of adipose tissue began to take hold, identifying the endothelial cell and the microvascular endothelial cells of fat tissue as the source of adipocytes, as well as many other cells in adipose tissue. And you see in the slide, in the series of studies, there are a number of different techniques that were utilized, including cellular markers, the zinc finger protein 423, as well as a number of studies that use cell lineage mapping. That in these studies, they really began to formulate the final conclusion that it was the endothelial cell, and in some ways perivascular endothelial cells, that were the critical cell to the formation of adipocytes and other cells in adipose tissue. I give you now what I consider my view on the origin of cells in adipose tissue. These cells originate from mesodermal cells and the formation of a presumptive stem cell, original stem cell called the hemangioblast. The hemangioblast gives rise to a blood island where hematopoietic stem cells and primary vascular cells are formed. The primary vascular plexus goes on to form the original microvascular networks inside the mammalian embryo. And this microvascular network continues to develop and expand through a number of different processes. Most importantly, based upon the extensive review of the literature, we find 3 different cells that can give rise to all of these cells inside adipose tissue. These are perovascular cells, cells in close association with the endothelium of the microcirculation, the endothelial cell themselves, and then a group of cells known as tip cells that are found as new blood vessels are formed, utilizing the process known as angiogenesis. These tip cells are also known as angiogenic sprouts. So the cells that can be derived from these perovascular cells, endothelial cells, and tip cells are vascular smooth muscle cells that then are incorporated into a new adipose microcirculation. Hemogenic endothelial cells, these are endothelial cells that by themselves can form other hematopoietic cells. A pre-adipocyte that can then form a adipocyte inside the newly developing fat. And these pre-adipocytes are often considered to be, the perovascular cells, the endothelial cells, or the tip cells. There are also hematopoietic stem cells that can be generated, again, directly from these endothelial cell-derived cells. And then finally, lymphatic endothelial cells that derive from, again, the endothelium of the developing fat. Lymphatic vasculature is found in adipose tissue. And then there are 2 final cell types that you can find in adipose tissue. One is circulating cells that arrive through the vasculature of the fat, diapedese in, migrate into the fat, and take residence there. And then sympathetic innervation. Fat is innervated and it is regulated by a sympathetic innervation. There have been 2 studies, very few studies. These are the 2 which I find to provide what the percentage of cells are inside adult adipose tissue. You take a piece of fat, you fix it, you section it, and then you use immunocytochemistry to determine the relative concentration of cells in fat. And a study by Williams, my group, in 1994, and then a study by Ito from 2009. This is the relative percentage of cells inside fat. And it's very interesting to see that about 12% of the cells in fat are adipocytes. About 25% of the cells in fat are what I call the formed element cells, leukocytes, M1 and M2 macrophages, T regulatory cells, and monocytes. About 2% of the cells found in fat are perivascular cells. And I'll mention here first, a majority of these perivascular cells are the smooth muscle cells that wrap themselves around the arterioles and the venules of the microcirculation in fat. And then finally, the endothelial cell. About 61% of the cells found in fat by direct visualization are the endothelial cells. So that leads us to the conclusion, what cell populations in fat are derived from endothelial cells? It's the adipocytes themselves, the new capillaries, the arterioles and venules that collectively make up the microcirculation of fat, lymphatic endothelial cells, and then these perivascular cells, which I'll talk about in a moment in a little bit more detail. The cells in fat derived from the endothelial cells can also be the hematopoietic cells that can give rise to new blood cells, and then the hemogenic endothelium. So what about parasites, fibroblasts, mesenchymal stem, cells and adipose stem cells? Well, first of all, the parasite. The parasite population in fat is relatively small to essentially non-existent. There are paravascular cells that surround the endothelium, but these cells are predominantly vascular smooth muscle cells found in arterioles and in venules. Other paravascular cells that originate from the blood and the endothelium are cells that are in close association with the endothelial cells, but they are not the parasites that are found in many other microcirculations inside the body, but not in fat. The fibroblast, which is often used as an earlier stem cell giving rise to adipocytes. The term fibroblast is a morphological phenotype. It is not a cell type. These are stellate cells that are found often in connective tissue, but they are, and again, this is my opinion, they are not a specific cell type inside the body. They are just a morphologic phenotype. We'll also see this when I discuss the culture of cells from fat. You can find fibroblastic cells by phenotype in these cultures, but they are not a specific cell type. The adipose stem cells in the early development of adipocytes are the endothelium. And then finally, this term, mesenchymal stem cells. I consider this a nomenclature that is flawed for several reasons. One, there is a highly selective set of CD markers that have been propagated, especially by specific cell societies, to define this mesenchymal stem cell. These CD markers are transient in nature many times in these cell types. And the mesenchymal stem cell is, again, what I considered a flawed nomenclature based upon CD markers. This mesenchymal stem cell has been perpetuated by the FDA and their regulatory definitions that include chemistry, manufacturing, and controls, the CMCs, indications, potency, dosing, and quality systems. The term MSCs has been perpetuated by a hierarchical, reductionist approach to adipose science. Our need to have a simple explanation of what gives rise to adipocytes has all of a sudden identified this MSC as the stem cell for all adipocytes and all cells within adipose tissue. And I consider this an oversimplification of the process, and also the MSCs overlook a major cell type inside fat, which is the therapeutic and regenerative cells. These are cells that are not necessarily stem cells, but are highly therapeutic and can help regenerate many tissues inside the body. So I leave you with an inconvenient truth. With the exception of nerve cells and circulating cells that invade adipose tissue, all cells in fat are originally derived from endothelial cells. Now, I've focused mostly on this early phase of adipose tissue development, what I consider part one, from the embryo to adolescence. In a subsequent presentation, I'm going to be talking more about the development and the expansion of adipose tissue from the period adolescence through the adult. I also want to mention that there are many types of fat. First, the visceral fat, and you see in this slide all of the different types of visceral fat that can be found throughout the human body, which includes intramuscular adipose tissue. I mentioned these different types of fat, one, that they have different functions, they have different histology, but we can utilize these sites of fat for subsequent isolation of adipose cells. And finally, subcutaneous fat. There are multiple types of subcutaneous fat throughout the body. I've studied many of these sites and ways of isolating this fat using a process known as liposuction. However, it should be considered that each of these different sources of fat will lead to a different cellular composition once the fat is isolated and the cells are isolated from the fat. I encourage everyone who's listening to this presentation to go to my website at cvregen.com. I'm posting these presentations on the website, as well as a lot of other information and additional presentations on the types of cells in fat, how to isolate the cells, and then how to therapeutically utilize these cells for clinical applications. Thank you.